Something is eating the sun, and we didn't notice for 3 years. In 2026, solar output dropped 0.1%. Scientists assumed measurement error. Then it dropped again, and again by 2029, the drop was undeniable and accelerating. A Russian astrophysicist named Irina Petrova was searching for the cause when she found something in the data no one had looked for: a spectral line, a specific infrared signature at 25.984 micrometers. Something in the solar atmosphere was emitting it, something alive. They named it astrophage, a single-celled organism. It lives in the photosphere of the sun, the outer layer where light is born. It feeds on that light directly, and it converts mass to energy with efficiency that makes nuclear fusion look crude. Here's what that means in numbers. A kilogram of hydrogen bomb fuel releases about 83 terajoules. A kilogram of astrophage releases 97 petajoules. That's not a small difference. That's 1,000 times more energy per kilogram than the most powerful weapons humans have ever built. The Petrova line, that spectral signature at 25.984 micrometers, became the fingerprint. Wherever astrophage was metabolizing, that line appeared. Astronomers began pointing telescopes at other stars. The line was everywhere. Every star in the neighborhood of the sun was showing the same dimming. Astrophage was an interstellar epidemic. How does a single-celled organism cross the void between stars? It stores enough energy to propel itself. A single astrophage cell, fully loaded with energy, can accelerate to 0.04% the speed of light. Between stars, that's slow, but given thousands of years, and space between stars is patient, it works. The crisis timeline was brutal. A 1% drop in solar output triggers global cooling. A 2% drop collapses agriculture at the poles. Projections showed 4% within 30 years. That's not a climate challenge, that's the end of civilization, billions dead within a century. Then one star broke the pattern. Tau Ceti, 12 light years away, was not dimming. Its astrophage population was stable. Something at Tau Ceti was keeping it in check. Something was killing astrophage there, or eating it, or preventing it from reproducing. If scientists could figure out what, they might be able to replicate it at our sun. The mission that emerged from this discovery was called Project Hail Mary. Send one ship, send it to Tau Ceti, find the answer, bring it back. The name was intentional. A last-second desperate throw with everything on the line. The ship's propulsion system was astrophage itself. Humans couldn't replicate the organism's energy efficiency artificially, but they could harvest it, breed it in controlled environments, feed it light, then use it as fuel. With astrophage, a ship could reach a meaningful fraction of the speed of light. Tau Ceti in roughly 4 years. The crew was 3 people. The mission length was more than a decade, round trip. To survive that, they would spend most of the journey in medically induced comas. Automated systems would wake them near Tau Ceti. The problem was the cognitive load of launching. Too many people knew too much, so the crew's memories were chemically erased before departure. They would wake up not knowing why they were there. One of them would wake up alone. The others didn't survive the coma. That person would have to piece together the mission, the crisis, and his own identity, alone 12 light years from Earth, with the fate of humanity depending on what he did next. Near Tau Ceti, he found something unexpected. Another ship from another star, sent by another species facing the same extinction. 2 beings, 2 civilizations, both dying, and both arriving at the same place, at the same time, looking for the same